Hello friends, welcome to the next short video which is on quick review of SCR or thyristors. This is in continuation with my short videos of the subject power electronics which are made for 4th semester electrical engineering students of Gujarat Technological University. So let's catch on with the today's topic, that is silicon controlled rectifier, or shortly known as SCR. So an SCR is a 3-terminal 4-layer devices. PN 4 layers are there. A thyristor, it's also known as thyristor, usually has 3 electrodes. An electrode, there is an anode, cathode, and a gate. The most common type of thyristor is a silicon control rectifier. A thyristor is a group of devices where we are discussing over here is SCR. Popularly, they are known as SCR and thyristor, commonly used as a synonyms also. But thyristor is a group of devices, and SCR is one of the device which is very popularly and commonly used. The thyristor name is derived from the combination of two devices, thyrotron and transistor. So thyrotron tubes were used previously for large power rating applications, and transistor, as you already know, is known for its good switching and other characteristics, say turning on by base current and all. So a combination of these two is called a thyristor. It is thyrotron plus transistor is equal to thyristor. It can handle high currents and high voltages, and that's why it is very better for high power ratings. It is having improved breakdown voltage also and better switching speed. Just look at the ratings. Typical ratings are available in kiloamperes and kilovolts. So in megawatt capacity, power handling capacity is there. No power electronic devices is having such a large power handling capacity, and it can be controlled with a very, you can say, a small gate current as it is shown. These days, the other devices like GTU and IGBTs are taking up, which are better, and they are now replacing thyristors. But so far, thyristor is the device which is a power switch for large power rating applications. Now here is the construction of the SCR. You can see PN 4 layers, and they are forming 3 PN junctions, J1, J2, and J3. When anode is positive with respect to cathode, junction J1 and J3, they are forward bias. When this is positive, so this junction J1 and this junction J2 gets forward bias, but J2 remains reverse bias. So this state is a off state. You can say this is popularly known as a forward blocking state also. So the switch is ready to conduct, but it is in off state, and you can turn it on by a gate signal. We'll discuss how. When anode is negative with respect to cathode, that means when the reverse supply is applied, both the junctions are in reverse bias. So the device is completely in a blocking mode. It is called reverse blocking mode. So it is in this mode, it is used just to prevent the that is off state, of complete off state, where it can never conduct, right? So how to turn it on? So at SCR, you can turn it on by applying positive to anode and negative to cathode, and at the same time, the junction J2, which was reverse bias, needs to that you are supposed to, that depletion region which is there at J2, you need to eliminate it. So by applying a forward bias at junction at that gate with respect to cathode, you are able to do that. So now SCR is turned on when a gate current is applied, and junction J2, which was having depletion region, is now that removed depletion region. So now the forward current from anode to cathode flows. The on-state anode current must be more than the rated minimum current known as a latching current. So when this forward current is more than the latching current, then only this device gets completely turned on. Once SCR is turned on and anode current is greater than the latching current, it remains in the on state even if the gate current or gate signal is removed. This is very interesting. So gate signal is just required to rather latch it, turn it on. Then continuously it is not required. Gate current or gate signal is not required continuously. It is required only for short interval during turn it on. Continuous gate signal is not required. That's what we have already discussed. What is latching current over here? The latching current is the minimum on-state current which is required so that the transistor, SCR goes into complete on state. So this ensures that the junction J2 is completely, the depletion region is removed, and the carrier signals, majority carrier signals, which ensures the smooth flow is equal to the latching current. So it is the minimum on-state anode current to continue on-state of the thyristor. It ensures junction J2 does not develop the depletion region again, because the polarities are such that junction J2 is reverse bias. Now, how to turn it off? SCR cannot be turned off by removing gate signal. We have already seen once it is forward bias, the polarities of anode and cathode are same. Removing gate signal is not going to turn it off. That's why called semi-controlled switch. The on operation can be controlled, but off operation, that is turning off, is not controlled. It cannot be turned off as long as the anode current is higher than a certain minimum value of current that is known as holding current. So this is the limitation rather, or a feature of a SCR. To turn it off, the forward anode current must be brought down to the values less than holding current. Now it is, if suppose it is used with the DC supplies where polarities are still in this plus minus. So, and if the load current is not reduced by the load itself, then the turning off is difficult, right? So that is the limitation of thyristor. SCR remains on even if the polarities of anode cathode are reverse. You can see here the anode is negative and cathode is positive, but current is still going on. Now, when is going to happen? This is going to happen inductive load. So in inductive load, current is lagging behind the voltage. So voltage has reversed, but current is still in the forward or positive direction. So in this situation, as anode current is not less than holding current, the device will continue to remain on, though the polarities are reverse. Anode is negative and cathode is positive. So when the polarities are in a forward bias region or polarities are in reverse bias region, but the device will remain on if the current through it, forward current, anode cathode current, is not reduced below a minimum level known as a holding current, right? In short, SCR is difficult to turn off, and a special commutation circuits are required in some cases, right? And these circuits force this forward current to go below the holding current, and that's how it is turned off. The basic PNPN structure of the SCR is shown over here. Anode is a highly doped P structure. Then in between you have a drift region N minus. Then P2 with a highly doped P plus region, and then you have a 2N plus regions forming the cathode, right? So this is how the vertical structure looks like. Now the VI characteristics of SCR. As you can see over here, it's forward characteristics. You are having a forward voltage, that is positive voltage to anode, and negative to cathode. So forward voltage is applied. Then this is the current. This is the level of you can say current. When you apply a gate signal and the forward current is more than this value, so this value is known as the latching current. Then this switch gets turned on, and now you have a large anode current flowing, right? The value this switching on, turning on, you can achieve at a lesser forward voltage if the more gate current is applied, as you can see over here. So this is the forward state or on state characteristics of SCR. In the reverse state, you can see it is similar to a reverse bias diode only. So it blocks voltage up to this voltage rating, and this is the breakdown voltage. and after which large current is going to flow. Now, when you reduce the forward current, suppose somehow the current is reduced, then after this holding current, you can see this holding current is little bit lower than the latching current. So once the forward current is reduced than this holding current, then only it will get switched off, and then you will have a large voltage once again develop, and that means the thyristor has gone into off state. So SCR operating modes, as we have already discussed, let's summarize. Forward blocking mode, when the positive which is of anode is applied with respect to cathode, but gate signal is not applied, and forward voltage is not very large, so the breakdown is not expected. Forward conduction mode is when you have forward biased, that is anode is positive, cathode is negative, and a sufficiently large gate signal is applied so that forward current flows which is larger than the latching current, and the switch is going to remain on state unless and until the current falls below the holding current. The reverse blocking mode, once we have already discussed, is when you are giving anode negative and cathode positive. So here both the junction J1 and J3 are reverse bias. So this mode is completely blocking the voltage and completely turn off switch. So now, in short, what are the features of SCR? It's a semi-controlled switch. Only turn-on operation can be controlled. It is a unidirectional. I have not mentioned over here, but the current can flow in only one direction from anode to cathode. Reverse direction current can never flow in SCR. The switch on can be controlled by gate current. We have seen. Switch off can't be controlled. Of course, special circuits are required, but just by removing gate signals, you cannot switch it off. And it is suitable for large power rating applications, control rectifiers, power controls, motor control, DC motor control. So high frequency heating, cycloconverters. There are a lot of high power, high rating applications where SCR was previously used. Now, these days, GTUs and IGBTs are replacing it, but so far, this is the state of the art, right? So that's all about the thyristor family and its most important member, SCR, right? So this was all about the power switching devices, which we are going to discuss in this syllabus. There are many other devices, special devices, but in this syllabus, we are going to discuss about all this only. So we have discussed power diode, we have discussed power BJT, MOSFET, IGBT, and SCR. The other devices we are going to discuss in our laboratory class, but they are not there as a part of your syllabus. So we are going to discuss the subsequent sections in which we are going to discuss the triggering methods of SCR and turning off method of the SCR, right? So that's all about SCR in this brief video. Once again, I'm repeating, this is for quick review of the topic SCR. For detailed understanding, one must refer to good reference and textbooks, right? I hope you enjoyed the video. And thank you. If you have any questions, you can put in the comment section. I will try my level best to answer them. Thank you.